carry it out. We'll talk about why it's of interest to know that later, but we'd like to know that. We can take these reactions, in fact, I'm going to label them reactions 1, 2, and 3, not 1, 2, and 2, 3. And I'm sort of running out of room here, so I think I'm going to go over there. We want to make borane. What's the first reactant in that top reaction to make borane?
Hydrogen.
Hydrogen. In reactions 1, 2, and 3, do any of those start with hydrogen? So let's take reaction 3, which starts with hydrogen. Does that have enough hydrogen?
Nope.
We need 3 hydrogens, so we need 3 times reaction 3. And that's which one? That's burning oxygen, burning with oxygen. And if we take 3 times that reaction, we have 3 times the enthalpy for one of them. What's the next reactant in that top one? Boron. Does reaction 1, 2, or 3 have boron on the reactant side? Does it have the right amount of boron? So we can just take 1 of reaction 2. What is reaction 2? The burning of it. It takes 3 halves oxygen to make B2O3. And that enthalpy was minus 2368. 2368 kilojoules per mole. We have some extra stuff in there now, some stuff we don't want. That top reaction does not have diboron trioxide in it. So we need to get rid of the diboron trioxide. We've used reactions 3 and 2. Reaction 1 must be the one we need here. In fact, it does have boron trioxide, but it's on the wrong side. We can flip that reaction backwards and run it the opposite direction. It may or may not be reversible in real life, but we can consider taking it in the opposite direction. So we're going to take the negative of reaction 1. So on the reactant side, we now have diboron trioxide, solid, plus, which one's 1? 3H2O goes to B2H6 and 3O2. And because we took the negative of that reaction, the enthalpy is the negative of negative 1941. We have a double negative there. Now, if we were to add all 3 of those reactions, what would we get? Well, if we add them, we have diboron trioxide on the reactant side here, and on the product side there. We can cancel that out. We have 3 waters on the reactant side here, and on the product side there. We can cancel those out. And we have 3 halves plus 3 halves oxygen on the reactant side. What's 3 halves plus 3 halves? 3. We've got 3 oxygen on the reactant side and 3 on the product side. So that can cancel out. Notice I'm using different colors and different symbols for canceling out so you can see what cancels. And what do we have left? 3 hydrogen plus 2 boron, nothing else on the reactant side. On the product side, the only thing we have is diborane. And that is precisely the gas at the very top of the board, that the reaction at the top of the board that we wanted the enthalpy change for. That's exactly that top reaction.
How would you determine the rate determining step on it?
I wouldn't. That's kinetics. This has nothing to do with kinetics. Whatever we do to these reactions, taking 3 times that and the negative of that, we do to the enthalpies. If we've added the reaction, we can add the enthalpies in exactly the same way. And the answer is sitting in my notes up there on the front desk. But if we add all of those together, we find that this reaction has an enthalpy of reaction. I'm getting black marks all over myself. Of negative 1152 kilojoules per mole. And that's the enthalpy of reaction for this particular reaction. What I've just shown you is actually known as Hessen's law of heat summation.